So in this specific example, what is given? The body weight of healthy 3-month-old colt should be about 60 kg. So this is in journal. It is given that the body weight of a healthy 3-month-old colt should be 60 kgs. Okay, now part A. If you want to set up a statistical test to challenge the claim that mu is equal to 60 kg, what would you use for the null hypothesis? So in first part we need to get what will be the null hypothesis. Okay, so now what we want to test in this, we want to challenge the claim that the body weight of a healthy 3-month-old colt should be 60 kg. So as per the definition of null hypothesis, we always agree with the statement. So here we say that in part A that the body weight of, we agree that the body weight of a healthy 3-month-old colt is 60 kgs. So our null hypothesis become H naught mu is equal to 60 kg. It's not necessary that you get this symbol mu here in the question all the time. Okay. Now in part B, this is part A. In Nevada, there are many herds of wild horses. Suppose you want to test the claim that average weight of a wild Nevada colt, which is another name for 3 months old, means Nevada colt which is of 3 months old is less than 60 kg. So here it is mentioned that what you want to test, that it is less than 60 kg. So what will be your alternative hypothesis in this case? So in part B, as we are saying that what you want to test, the average weight is less than 60 kg. So mu less than 60 kg, because you want to test that average weight is less than 60 kg. So this gives you mu less than equal to 60. Similarly for C, suppose you want to test the claim that the average weight of such a wild colt is greater than 60. So here HA will become mu greater than 60 kg. And D, suppose you want to test the claim that the average weight of such wild colt is different. Now the word is different, so you're not talking about it's more or less. You are just saying that it is not 60 kg, it is different. So this is on the basis of different criteria how you will make your alternative hypothesis. So when these two are one-tail test, if you are going with this, and this will be two-tail test. Okay, and as we know that this is called the right-tailed or right-sided, and if null alternate hypothesis like this, it will be called as left-sided test or left-tail test. Okay. Similarly, you have another question where again you have to frame the null and alternative hypothesis. This is another example where we see the application of hypothesis testing in marketing situation. How much customers buy is a direct result of how much time they spend in a store. A study of average shopping times in a large national warehouse store gave the following information. This is the source given to you. Woman with a female companion, they will spend 8.3 minutes. and women with a male companion spend 4.5 minutes. Suppose you want to set up a statistical test to challenge the claim that a woman with a female friend spends an average of 8.3 minutes shopping in such a store. Okay, so what you have to do in part A? What would you use for null and alternate hypothesis if you believe that the average shopping time is less than 8.3 minutes? Okay, and then you have to classify it as a right tail, left tail or two tail test. So here what is there given? It is given that when women goes with a female companion for shopping, they spend almost 8.3 minutes on an average, whereas when they go with a male companion, they spend on an average of 4.5 minutes of time for the shopping. Now we want to set up a statistical test. Now what we want to test? We want to test the claim that a woman with a female friend spends 8.3 minutes shopping in such a store. So we are concerning about now this statement. So here null hypothesis. First of all, we say that okay, we agree with the claim that a woman with a female friend spends an average of 8.3 minutes. So null hypothesis will be mu is equal to 8.3 minutes. Now we need to set up alternate hypothesis. So alternative hypothesis, what we have to phrase from here? We have to, what you see this question, what would you use for the null and alternative hypothesis if you believe the average shopping time is less than 8.3 minutes? So here in this case mu is less than 8.3 minutes. This will be your alternative hypothesis. So now what you will get here? Next is you need to tell whether it is a left tail, right tail or two tails test. So definitely less than, so it means it is a left sided, or you can also say as left tailed test. Okay, now let's go to part B. What would you use for null and alternative hypothesis if you believe the average shopping time is different from 8.3 minutes? So here the null hypothesis will be same because we are testing the average time, which is 8.3 minutes. So we agree with the statement that okay, average time is 8.3. Now alternative hypothesis, suppose if it is not 8.3, then what it will be? It is mu. Now we have the word different. Now we are talking that it is not 8.3 minutes. We are not saying that it is less than or more than, but it's not. So for not we say not equal 8.3 minute. And we know that when test is of this category, it is a two-sided or two-tailed test. So let's do it. What is it? We can see again use these hypothesis testing in the meteorology. So what it says? Weatherwise magazine is published in association with American Meteorological Society. Volume 46 number 6 has a rating system to classify northeastern storms that frequently hit New England states and can cause much damage near the ocean coast. A severe storm has an average peak wave height of 16.4 feet for waves hitting the shore. Okay, so we have this information. They said that a severe storm has an average means mean, average peak wave height of 16.4 feet, okay, for the waves hitting the shore. Suppose that a nor'easter is in progress at the severe storm class rating. Okay, then part A. Let us say that we want to set up a statistical test to see if the wave action is dying down or getting worse. What would be null hypothesis for this? So we would like to know that what will be the behavior, what will be the average height of the waves. So they are asking for, in this case, what will be the null hypothesis. So as usual, null hypothesis, we agree with the claim always. So we say that the average height of the wave is 16.4 feet. Okay, in part B. If you want to test the hypothesis that the storms is getting worse, what would you use as alternative hypothesis? Now storms are getting worse means the average height is becoming more. See, how do you know that thing? Because it's mentioned that statistical test is set up to see if the wave action, which is based on height, is dying down. Dying down means it's going less, or getting worse. Getting worse means it's becoming more. So here the alternate hypothesis will be mu greater than 16.4 feet. So now this is right-sided test. Okay. Now let's consider this question and we will complete the solution. Let's read it. Rosie is an aging sheepdog in Montana who gets regular checkups from her owner, the local veterinarian. Let X be a random variable that represents Rosie's resting heart rate, which is measured in beats per minute. From past experience, the vet knows that X has a normal distribution with sigma is equal to 12. So this means the standard deviation for the population. The vet checked the Merck veterinary manual and found that for the dogs of this breed, mu is 115 beats per minute. So means the average heart rate is 115 per minute. Okay, so this information is given to you. Now here it is mentioned in the symbolical term. Sometimes the symbols are not mentioned. In place of symbol, they will write the expression, the standard deviation, average mean. Okay. Now, so what you got information so far? From population, we got mean, which is given as mu, which is 115, and the standard deviation sigma, which is 12. This is the information that we got so far. Okay, over past 6 weeks, Rosie heart rate measured as these numbers. So now we are talking about the sample. Okay, so now this heartbeat rate is in the past 6 weeks. So what is the size of the sample? 6 weeks. Okay, now the sample mean is given as 105.0. Now suppose sample mean is not given. When you have this information, when you have the data, you can easily calculate the average. I hope you remember how to calculate the average. Suppose you have 3 numbers and you want to find their average. What you will do? 275 divided by 3 to get the average. Okay, and the same way you have 6 numbers and you want the average. So you can calculate the average if it is not given here. Okay, so average is nothing but the sample mean, but as it is given here, so it will be 105. The vet is concerned that Rosie's heart rate may be slowing down. May be slowing. Do the data indicate that this is the case? Here we consider alpha to be 0.01 or 1% level of significance. So we have to work on this. Suppose for instance this line is missing from there, that they don't give you the sample mean, then you should be able to calculate the sample mean. So from this information what you can see, you have the mean and standard deviation for population and mean and size of the sample from the sample. So it means it is a z-test. So before going for that, we should phrase our null hypothesis and the alternative hypothesis. So what is the null hypothesis? Here what we want to test, the vet is concerned that Rosie's heart rate may be slowing. So slowing means it's becoming less. That comes in the alternative hypothesis. So earlier we will, for the null hypothesis, we go with the claim that okay, her heart rate is not decreasing and it is 115 beats per minute as per the dogs of this breed. Okay, and the null alternative is we go with the concern of the veterinary here. It's like it's slowing, so it means we say that it is less than 115. Now so it means it is a left tailed test. So see, this is always, it's a very important to have the null hypothesis and alternative hypothesis, because then only you can able to make your decision. Okay, now you have these quantities, you have mu, sigma, n and x bar, and we know that we have to use z-test. So calculate the z value, which is x bar minus mu over sigma multiply by square root of n. You have all these values substituted here. X bar is 105 minus mu is 115 over sigma, which is 12 times root 6. Use a calculator and calculate it. This comes out to be minus 2.04. Okay, so let's write down this value. So this is the value from the calculation. Now we have to compare this z value from the table. This is z value from the calculation. Now we need to compare it from the table. So to calculate the value from table, how do we see the table? We have left tail test, and alpha is 0.01. So what value we will get from table? So when we look for the z table, it is this last column, last row. So it is one tail test, alpha is 0.01. It means we look into this section and here it comes out to be 2.326. So we got the value from the table as 2.326. So let's write down these things. Z value by calculation. What is it coming out? It is minus 2.04. Now Z value from table. It is 2.326. How do we get the value from table? We look for alpha is equal to 0.01 and one tailed test. Okay. Now we are going to work on this. We use this value to get the critical region. So how do we define the critical region? This is the value from the table. So we draw a numbered line. This is the point 0. This is the, we put points on this line on this point 2.326, positive and negative. Okay, so critical region is always towards the left side of the negative value and towards the right side of the positive value. So this is your critical region. Critical region. Critical region or the region of rejection. Now what we need to do is we need to check where our calculated value lies. 2.04 minus. It lies in the critical region or not. So our 2.04, if you plot it, it will come somewhere, say here, minus 2.04. So we say that our calculated value of z, which is minus 2.04, does not lies in the critical region. Hence, if it is not lying in the critical region, hence we do not reject the null hypothesis H naught. So it means what we are not rejecting, we are not rejecting the null hypothesis that mu is equal to 115. So it means that mu is equal to 115. So what we can say, what is it? It means the average heart rate of Rosie is 115 beats per minute. Okay, this is how we make the decision. So see, we are going to use these terms: fail to reject H naught or reject H naught. So we are always making decisions over the null hypothesis. So what is the meaning of fail to reject H naught? It means that there is not enough evidence in the data and the test being used to justify a rejection of H naught, to justify the rejection of the null hypothesis. Like there is not sufficient data that shows that the heart rate of Rosie is not 115. So that's the reason we are not able to reject that one. Okay. So this means that we retain H naught with the understanding that we have not proved it to be true beyond all doubts. Okay. And once we are rejecting H naught, what does it mean? There is enough evidence in the data and the test employed to justify rejection of H naught. This means that we choose the alternative hypothesis H1, or sometimes we known by HA, with the understanding that we have not proved that HA to be true beyond all doubt. So it means we are rejecting H naught, but we are not saying that HA is only going to be true. We are just rejecting the null hypothesis.